You start with a mountain of disorganized files, and then, piece by piece, the structure snaps into focus. This is how you build a video. Before computers, editing was a strictly physical process. You assembled cuts sequentially, slicing and taping one piece of magnetic tape directly to the next. Because of how these bulky reel-to-reel machines functioned, moving a single clip meant copying that tape. Every copy caused the image to permanently degrade, losing clarity with each pass. Today, we use non-linear editing systems. Instead of physical tape, we manipulate digital files across infinite layers. You can move, trim, or reverse any clip instantly without damaging the original file. Mastering this digital environment separates the amateur from professional. It is the process of transforming raw data into narrative power. Step 1 is organization. When you import your files, sort them immediately into color-coded bins for video, audio, and graphics to keep the workspace predictable. But even an organized project will freeze your software if you drop heavy 4K or log footage straight onto the timeline. High-resolution files require massive processing power, leading to stuttering playback and lag. Looking at this diagram, you can see why the massive 4K block gets stuck at the processor bottleneck. Creating a proxy, a smaller, low-resolution copy of your footage, allows the system to run smoothly. You edit with the proxy, and the software swaps the 4K original back in for the final export. With playback running smoothly, you begin the sifting phase. Instead of watching every second of a scene, you scrub directly to the final take, which typically features the best performance. From there, you set precise in and out points to mark the usable action, then aggressively delete the remaining footage from the timeline. This animation illustrates the result, a massive, sprawling hour of raw footage collapsing into a dense 5-minute core of isolated assets. Now we establish the rhythm. You lay down the voiceover and the music track first, using the audio to dictate exactly where the visual cuts will fall. To make the dialogue transitions feel natural, editors use a technique called the L-cut. As this timeline abstraction shows, an L-cut occurs when the audio track from the first clip extends to the right, continuing to play underneath the video of the second clip. Letting the speaker's voice overlap the reaction shot visually masks the hard cut. This mimics how we perceive a conversation in the real world. Next, we process that audio. Raw microphone recordings often carry a muddy sound, filled with low-end rumble from wind or electrical hum. This EQ curve demonstrates how a high-pass filter solves the problem. The chaotic low frequencies on the left are chopped off at a strict threshold, leaving only the clean, crisp frequencies of the human voice. You follow this by applying soft compression to level out volume spikes, and automate the music track to lower whenever someone speaks. You then build out the environment by layering sound effects, like heavy impacts or ambient room tone. These subconscious cues signal the weight of an object or the scale of a room, grounding the edit in a physical reality. A finished audio mix provides the technical and subconscious framework that makes a digital sequence feel immersive and real. With the audio locked, you move to the visual polish. This two-step process begins with color correction. You use scopes to neutralize flat log footage, adjusting the exposure to hit pure black and pure white. Once the baseline is accurate, you move to color grading. This is the application of stylized LUTs to push specific colors into the image to establish a mood. This split screen shows why the two steps remain separate. You start with the gray raw log on the left, fix the exposure in the color-corrected middle, and then apply the stylized final color grade on the right. You also use on-screen text to guide the viewer's eye. Kinetic typography allows you to emphasize critical data points without breaking visual momentum. You set keyframes so the text scales or bounces in sync with the audio, physically commanding the viewer's attention. Color and kinetic typography function as engineered psychological tools, forcing the viewer's focus onto the most critical parts of the frame. Now you export the file. An improper configuration here results in unwatchable pixelation, or a file too massive to upload. Modern platforms require specific baseline settings. The H.264 codec, matched to a 4K resolution of 3840 by 2160 pixels. Looking at this export menu, you see the critical mathematical threshold for 4K video. The variable bitrate, or VBR, is dialed in precisely between 35 and 45 megabits per second. Adhering strictly to these bitrate parameters gives the file enough data to survive aggressive compression algorithms during the upload. When you hit render, these isolated elements lock together. The sharp color, clean audio, and kinetic text operate as a single, unified mechanism. We started with chaotic, disorganized data. We sifted, organized, and sculpted that data into a sound narrative structure. Success depends on a strict chronology: organize, sift, cut to the audio, mix the sound, grade the color, and export to exact specifications. Commanding a predictable workflow allows an editor to solve complex narrative problems through logic and precision.